Hello everyone and welcome to the Top Hat Learning Lab. Today we'll be talking about assumption problems. Assumption is a way of solving different types of math problems. And the basic process is 1. To assume, 2. To find the differences, and 3. To substitute. Now, I'll be showing that process on the next example. So let's get right into it. On our top left-hand corner we have our first problem. A robber locked some chickens and rabbits in a cage. Together there are 30 heads and 88 feet. How many chickens and rabbits are there? So, I'll write out the assumption process. We have 1. Assume. 2. Find the differences. And 3. Substitute. Now, we can try this process in this example. So it's asking for how many chickens and rabbits there are. We're going to assume that all of the heads are chickens. Now, all chickens have 2 feet. So 30 heads times 2 would give us 60 feet. Now this is our assumption, which is different from the actual question. So we're assuming that if they're all chickens, there'd be 60 feet. But obviously they aren't. There aren't all chickens, because there are 88 feet compared to our 60 feet. Why is this? This is because we have rabbits as well. And rabbits have 4 feet. Now, you might think that rabbits have 2 and actually have 2 arms, but for simplicity, all rabbits have 4 feet here. So, because the rabbits have 4 feet, they are adding on feet for every chicken. So, if we substitute 1 rabbit for a chicken, that would mean that since rabbits have 4 feet, that would mean there'd be 2 more feet. Now, in total, there's a difference of 28 feet. So that means that there are 28 feet that belong to rabbits. Now, how do we figure out how many rabbits there are? We can simply divide 28 by 2, and that would give us 14 rabbits. Now, if you want to find how many chickens there are, it would be 30 subtract 14, and that would give us 16 chickens. So, what have you noticed? If we substitute them all for chickens, so we substituted them all for chickens, but we ended up with the number of rabbits first. So every time you if you assume they're all chickens, you'll get the number of rabbits. If you assume that they're all rabbits, then you'll get the number of chickens. So just keep that in mind, because these belong to rabbits. If you did it the other way around, you'd have more feet. So let's try it. If all of these 30 heads belong to rabbits, then you'd have 120 feet. And 120 subtract 88 would give us 32 that belong to chicken. Now, if you divide 32 by 2, you'd get 16 chickens, which is exactly what we have over here. So now that we know that both ways work, let's move on to our next problem. There's a pile of black and red checkers. The number of black checkers is 2 times the number of red checkers. You repeatedly take 4 black checkers and 3 red checkers from the pile each time. How many times do you need to take checkers to result in 1 red checker and 18 black ones left? So once again, we're going to assume. Because 4 black checkers and 3 red checkers is a bit hard to deal with, let's make these 3 2 red checkers. So let's assume that you take 4 black checkers and 2 red checkers each time. Now, that would mean that the number of black will always be 2 times as many, because it starts as 2 times. So, for example, if you had 22 black and 11 red, that would mean that after you take 4 and you take 2 here, it would give you 18 and 9. And you see how the black one is still 2 times as many. Now, this works conveniently, because my next point is that since you have 18 black ones left, if you took 2 red each time and 4 black each time, you'd end up with 9 red ones. But that's not the case. So, I have another formula. If you want to use it, you can use it. So, we have the big difference, or the total difference. So, total. And you divide this by the small difference. Now, what do these actually represent? So the total difference is, let's move back to our chicken rabbit question. The total difference is the total in the situation here, 88 feet, subtract the total in your assumption. So in here, or the other way around, you just want the difference. So here, we have our total for our assumption, that's 9. Subtract 1 red checker in the actual situation, and that gives us 9 minus 1. And you divide by the small difference. Small difference is one single unit. So rabbits and chickens in this case. Rabbits have 4, chickens have 2, and you find the difference here. Here we actually only change red checkers, and we change it to 2 red checkers. So 3 red checkers and 2 red checkers. That's our small difference. And so this would give us, in this case, the number of times that you take, which I would represent with T. And that is actually 8 times. So you would take checkers 8 times to get 18 black ones and 1 red checker. Let's move on to our third problem. Mr. Cho has $5 bills, $10 bills, and $20 bills. He has a total of 100 bills and a total of $1,300. He has the same number of $10 bills and $20 bills. How many $5, $10, and $20 bills does he have? So once again, we are going to assume, but what do we assume? So since he has the same number of $10 and $20 bills, it's going to be easier to solve for those first. So, as we said before, for the chicken and rabbit one, if you want to solve for 10 and 20, you're going to have to assume that all of them are $5 bills. So if we assume that they're all $5 bills, the big difference would be 1,300 minus 5 times 100, which is the amount of money you have if they were all $5 bills. You'll divide this by the small difference, but what is the small difference? So in this case, the number of $10 bills and $20 bills are the same. So if we substitute the number of bills here for our assumption, we can substitute one $10 bill and one $20 bill for every 2 $5 bills. So that would give us, the small difference would be what we have here, $10 plus $20, subtract 5 times 2, which is the 2 $5 bills. So for every 2 $5 bills, we're going to substitute one $10 and one $20, and that'll give us the difference or increase in money. So if we put that into here, subtract 5 times 2, that will give us, so we're going to move this over here, that will give us 1,300 minus 500 divided by 30 minus 10, 20, which will also give us 40. Now what is this 40? This 40 represents the number of $10 bills or $20 bills. So I'm just going to choose $10 bills because there's going to be 40 $20 bills as well. And if you want to get the number of $5 bills, it would simply be 100 minus 80, and that gives you 20 $5 bills. Now finally, we're going to move on to our last question, which is Bob Bob. Bob Bob is writing a math contest. There's a total of 15 questions. For each one that he gets right, he gets 8 points. For each question that he answers incorrectly, he deducts 4 points. Bob Bob ended up with a total score of 72 points. How many did Bob Bob answer correctly? So, if we want to do this, let's assume that he did all of them correct, just to be optimistic. So if he got all of them right, he'd get 8 times 15. So the big difference would be 8 times 15. Subtract 72, which is its actual. You will divide this by 8 minus -4, which is the small difference. And that will give you how many he answered incorrectly. Now, if you know your integers, 8 minus -4 is actually just equal to 8 plus 4. And this side, you'll get 120 minus 72, which is equal to the number of incorrects. And this side will be 48 divided by 12, which will give you the number of incorrects, and this means that he got 4 incorrect. Now since you want to get the number that he got correct, you'll just subtract 4, and that gives you 11 correct. So Bob Bob got 11 questions correct. Now, you could also do it this way. 72 subtract -4 times 15 divide by 8 minus -4, and that gives you the number of correct answers. And if you do it this way, you'll get 112 divided by 12, which is equal to 11. Oh, sorry, 132 divided by 12, and that gives you 11 correct. So you end up with the same answer, and you could do it either way. And that is our lesson on assumption problems, and that's all we have for today. I hope this helped you, and I hope you learned something. I hope to see you next time, and thank you all for watching.